Hi everyone, welcome back. In this video, we will be talking about pH. We will be talking about what is acids, what are bases, and how can we define them. So before we delve into the definition of pH, we need to understand what is acids and bases. So we need to introduce a theory called the Arrhenius theory. And we have two parts of this theory. We have an original part and we have a modified theory. So as we know, if we have a beaker of water, these water molecules will occupy the space in the beaker. And when we put some solutions, or let's say some compound in, for example, sodium chloride, this compound will be dissociated into the two ions, the cation sodium and the anion chloride. So in fact, this beaker will look like we have some water molecule, we have the positive sodium ion and the negative chloride ion in this beaker. So when we have a ionic compound, they will undergo dissociation. And if we put some compound that has hydrogen in it, let's say hydrogen chloride, they will be dissociated into hydrogen and chloride. And based on the original Arrhenius theory, when we have an ionic compound which will undergo dissociation, if this dissociation results in a positive hydrogen ion, then we could call this acid. Based on the original in Arrhenius theory, if we have some compound that undergo dissociation and we have a hydroxide ion, then we would have a base. But technically, for acids, this dissociation for this hydrogen chloride, or sometimes we call it hydrochloric acid, is not technically not dissociation because this is a molecular compound. Therefore, we actually call this process ionization. So for a molecular compound like hydrogen chloride, if it undergo ionization and we have a positive hydrogen ion as a result product, we would call this an acid. Whereas if we have an ionic compound which will undergo dissociation, and if we have a hydroxide ion as one of the result products, we would have a base. For modified Arrhenius theory, we're trying to explain two anomalies. The first one is carbon dioxide. This is a molecular compound, and if we dissolve it in water, it is going to be an acid. However, there are no hydrogen ions present in this compound. So how does that work? So the modified Arrhenius theory takes water into account. So it says if we have this carbon dioxide which will react with water, we will have As a result of this reaction, we would have hydrogen carbonate. And we take this hydrogen carbonate, react with water again. We would actually have this and hydrogen carbonate ion. And this we call it a hydronium ion. And based on the modified Arrhenius theory, after a molecule undergo a reaction with water, somehow it results in the result products we have a hydronium ion. It will be considered as an acid. And how is this hydronium ion formed? So we would have a water molecule, and we would have all these hydrogen ions flowing around. And somehow, since as we learned in one of my previous videos, this water molecule is actually polar. We would have a polarity of, we would have a temporary, or not temporary, permanent molecular dipole on the top as negative, and a positive permanent molecular dipole at the end. So these two would attract each other. So it would form something like this. So some hydrogen ion will form a single bond right here with the whole molecule on the, right here. And this taken together is called a hydronium ion. The second anomaly would be ammonia. So when we dissolve ammonia in water, we would have a base empirically. However, there's no hydroxide in this molecule. So how can we explain this? So again, the modified Arrhenius theory takes the reaction with water into account. So when ammonia reacts with water, we would have ammonium and a hydroxide ion. So here is where the hydroxide ion comes from. Therefore, the modified Arrhenius theory suggests that when a molecule reacts with water and in the result products, we would have a hydroxide ion, it would be still considered as a base. Therefore, the modified Arrhenius theory combines the original Arrhenius theory and the reaction with water. That would be an introductory definition of acids and bases. And now we are going to talk about pH. So when we think about pH, we usually look at it as a scale on which the extent to which an acid is acidic or a base is basic is measured. So how does this work? So for acids and bases, we're actually trying to measure the concentration of either the hydrogen ion, or for pH, we're measuring for the concentration of hydrogen ion in a particular acidic solution or a basic solution. And if we have a pH of less than 7, we would have an acid. And we have a pH greater than 7, we would have a base. However, in order for this benchmark 7 to work, we must measure the pH of our solution in 25 degrees Celsius. Now we're going to introduce a concept called the ionization constant. And the ionization constant is equal to 1 times 10 to the power of negative 14 mole per liter altogether squared. And this applies to all aqueous solution. And this is the product of the concentration of the hydrogen ion and the concentration of the hydroxide ion. So when we're trying to communicate the concentration, we have the molar concentration of an acidic or basic solution. And this molar concentration would be in the unit of mole per liter. And then, in order to find the pH, we would have negative log our molar concentration. Or I'll use C to represent concentration. And the pH of a solution is the negative of the logarithm to the base 10 of the hydrogen ion concentration, which is mentioned here. And another concept is pOH, and pOH is simply the measure of the hydroxide ion in a solution. And this would be equal to 14 minus pH, as we calculate right here, under standard ambient temperature and pressure, which is 25 degrees Celsius and 100 kilopascal. And I think that's all for this video, where we covered the definition of acids and bases and the definition of pH. Thank you for watching.